Welcome. Thank you for joining us for the webinar, Accelerating Your OpenStack Cloud Deployment with Ubuntu OpenStack and PLUMgrid ONS. I'd like to start off with some quick housekeeping. So all of our guests are currently on mute for this session and will be so throughout. If you would like to ask any questions, we do welcome it. So please use the Q&A question panel and we'll do our best to answer them throughout the session. We will also save some time at the end to address any additional questions and questions that weren't able to be answered throughout the session. So without further ado, I'd like to pass this webinar over to Azmir to further the introductions and get started. Thank you.
Thanks, Deborah. Good morning, everyone, or good afternoon to Mark, who's joining me here from the UK today. We're going to spend about an hour talking about the collaboration between Ubuntu OpenStack and PLUMgrid ONS. Just to level set who your presenters are for today. I am Azmir Mohamed. I'm Senior Director of Products here at PLUMgrid. Spent a lot of time in the OpenStack ecosystem. If you've been to a meetup or a OpenStack Design Summit recently, you probably would have run into me. And that's my email address and my Twitter handle if you want to get in touch with me. But hopefully you'll find the time we spent today here useful in terms of what the two companies are doing together and what we're delivering for the OpenStack ecosystem. With me today is Mark Baker. Mark, why don't you go ahead and spend some time introducing yourself?
Yeah, sure. Thank you, Azmir. So my name is Mark Baker. I work for Canonical, and I'm the product manager for Ubuntu OpenStack. So we, I think, well, hopefully many people know Ubuntu, but have an OpenStack distribution, and I'm responsible for our go-to-market around that product. As Azmir said, I'm based in the UK. Actually, you mentioned meetups. We just had the London OpenStack meetup last night, celebrating the fifth OpenStack's birthday. So, welcome to any attendees from the UK. I hope you're joining.
Yeah, good point. Yeah, 5 years. It seems like it was only yesterday that kicked off this whole cloud revolution. So that's great news. So today, between myself and Mark, we'll cover a bunch of things. Mark will get started first. He'll cover an introduction into Ubuntu OpenStack, Juju Charms, give a little bit of background around the company and the products and really what they're doing here. I think you'll be very excited to hear about what Canonical has been up to. And then together we'll cover our partnership. It's recent, but we've made a lot of strides in a very short amount of time. Why we got together, we definitely believe that the combination of Canonical and PLUMgrid and our expertise in products is better together. And then we have time towards the end. We'll definitely go through Q&A, and then I'd love to be able to at least show you the charms that we've upstreamed as available today on the Juju Charm Store. So without further ado, I'm going to hand it over to Mark. Mark, why don't you go ahead and walk us through the company and the product, and let's get this webinar started.
All right, thank you. Yeah, so as you probably worked out just from my intro there, Canonical is the company behind Ubuntu. So hopefully most people in technology have at least heard of Ubuntu, a Linux-based operating system, fully open source, used initially, of course, in the desktop back in the day in 2005, but when we really started on this adventure. But as a server platform, really pushed hard into this emerging world of scale out and cloud that was starting to emerge sort of 2008 to 2009. So Canonical is the company that sits behind Ubuntu. So it's a worldwide organization, around 600 people, actually closer to 700 now, and geographically spread. So it's a number of here in the UK, but sort of 250 plus now in the US and many over in Asia too. Thank you, Azmir. Yeah, so founded in 2004, 700 plus employees now in 30 different countries. Very geographically spread. Make a point of hiring talent and not being too picky about where it is based. So hence we've got people in some far-flung places, but because they are the right people, the right developers, the right engineers working on those projects. So and a lot of the commercial engagements, all the commercial engagements that you see Ubuntu engaged in, whether it's Foundation, OpenStack Foundation membership, or whether it's preloads on servers that you may be buying or desktops or whatever, it is Canonical, the company behind it, the thing that's sort of leading that commercial engagement. And Canonical was founded by the same person. So who founded the Ubuntu project, which was, of course, Mark Shuttleworth. So if we move on into the next slide. Come on back. Thank you. One of the, as I said, Ubuntu is really because we started really developing Ubuntu Server in 2005, 2006, 2007. Linux in the data center was very well established at that point, and it for us meant that we didn't really want to go and say, well, we don't need another enterprise Linux in the data center. There's already some folks doing great jobs at that. And if you want to run your Oracle DB or SAP or whatever it is, there's some great solutions for Linux in the data center for that. But where do we see things that, where Ubuntu can make a difference? And there, as I say, just emerging within what we class as scale-out compute, right? So a lot of the sort of, I don't know if you call them scale-out or web scale, but big web application farms, whether hosting providers or whatever, and then especially in sort of 2008, 2009, when we see AWS coming online, this becoming a sort of very developer-centric area to try spinning up applications, try, fail, try, succeed type of environment. And there we thought, well, actually, Ubuntu can offer real value here. And we worked very hard with those hosting providers, cloud providers, and others to make Ubuntu a great platform for that web scale-up cloud computing environment. The follow-on from that, of course, was that when OpenStack started to emerge in 2010, like 2010, 2011, that was a great fit. We were already extremely popular on Amazon, as you see from the chart there. It's a little skewed, but there's from the chart there that somewhere between 60 to 70% of the workloads running in public cloud, whether it's Amazon and then of course it's the leaders, but then more lessly AWS, Azure and others. Ubuntu is extremely popular, running say 60 to 70+% of the workloads in that type of environment, on those environments. Then OpenStack comes along in 2010. We say, well, this looks like cloud computing, and it makes great sense for us that actually, as being one of the initial founders of OpenStack and being heavily involved in its inception, that we get involved in this. It looked like it was somewhere, again, we could add great value. And the net result of that was through, partly right place, right time, and right vision, but also some great engineering work, is that not only does Ubuntu enjoy a great deal of popularity in those public cloud environments, and say by far the biggest or most popular Linux running in those environments today, but it's also by far the most popular platform for running OpenStack today. So somewhere around 60%, 64%, I think it is, of OpenStack deployments today are in production are sitting on Ubuntu, and that's it means that we're heading in the right direction, and we're doing some great things at a technology level that keep our platform popular. If we move on to the next slide, though, it's not just about the operating system. So we saw, again, just like the early days of Linux, that OpenStack as a collection of projects that integrated together can provide you with a compelling cloud platform, that these things needed to be packaged and created into a distribution. And so even actually back in 2010, 2011, when we started packaging OpenStack and putting it in the archives and setting up the relationships between Nova and Glance and Swift and all the other components, we weren't actually calling it an OpenStack distribution at that point. We were just calling it was the cloud infrastructure that we were placing in archive. But the community decided actually let's call these things distributions, and so Ubuntu OpenStack. If you go, that's a screenshot there of the OpenStack marketplace. To go on openstack.org and /marketplace. In the distribution section, you'll find quite a few different OpenStack distributions now, but Ubuntu OpenStack is certainly one of the leading, if not the leading OpenStack distribution, and we're certainly one of the first to go into that space. And that means that a great many of the adopters of OpenStack have done so using Ubuntu OpenStack and running that naturally on Ubuntu operating systems. If we can again move to the next slide. The net result of that has been, number one in production. So as I said, somewhere around 65% of people running OpenStack into production today are doing so using Ubuntu. Some of them, the OS, a great many of them, we estimate we've got around certainly more than 2,000 users now running Ubuntu OpenStack, our distribution, in production today. And some of the names that you can see there, many of these have been on stage at the OpenStack Summits talking about their deployments. People like Best Buy, Time Warner Cable, of course, Cisco, and of course, we're using WebEx right now. The back end of WebEx sits on OpenStack that's running on top of Ubuntu. So this is not just snake oil or stories that we're talking about here. There are real life, very large customer deployments of Ubuntu OpenStack running there in production today. And hopefully those other names you'll recognize, Bloomberg, of course, being Financial Services, Stroke Media, and Sky being a media company. Commercially engaged with Canonical, deployed with Ubuntu OpenStack. If we just keep moving forward, what actually is Ubuntu OpenStack? Well, it's a comprehensive OpenStack distribution. And so it's, as you would expect, if we start from the bottom upwards on the right-hand side, Ubuntu, the LTS, long-term support edition of Ubuntu, which means it's supported for 5 years, runs on a number of different hardware architectures. Of course, Intel being probably the most popular there, not probably is, and certainly the most popular in the market, but also on top of ARM or Power 8 architectures too. So this is not just one architecture, but running in conjunction with, on top of Ubuntu, then we have the Ubuntu OpenStack components themselves. And so you'll see, of course, Nova, that's providing compute capability, and we can run that with multiple different hypervisor environments, KVM, probably the most popular in the OpenStack community, but also ESXi, Hyper-V, and then LexD, which is a daemon for running Linux containers, whether that's straight Linux containers or Docker containers. So it allows you to be able to interact with containers in a way, similar way that you would VM, providing some sort of portability and security, many security and portability benefits. All of the key components you would expect in an OpenStack distribution, Swift, Glass, Neutron, Telemeter, stroke telemetry, Keystone, all fully packaged, fully integrated, available through a very simple install. And then a number of supported guest environments. And so this is that white box you'll see there, Windows Server 2008, 2012. We have gone through the whole SVVP process and WCL certification for various drivers that you'll need to be able to run Windows guest in this environment on KVM. And of course, Ubuntu guest, but Oracle Linux and a great many customers running, of course, Red Hat in this environment. So all of those fully supported by us. On the left-hand side, we have the tools that we use to be able to manage and scale this environment. So I'm not going to talk too much about Juju because I'll build out on that in the next slides. But at the bottom, we have MAS, Metal as a Service, and this is really a hardware provisioning. It's automated hardware provisioning. So how do we if we want to be able to scale our cloud up, our OpenStack environment up, how do we add more Nova nodes, for example, by powering on servers, deploying Ubuntu onto them, deploying the OpenStack packages, connecting them into the environment. The first step of that process is using MAS. Landscape is a security systems management tool, so it allows us to be able to drive things like access control, audit and compliance, patching policy and security policy to all of the systems, whether they're running our cloud or whether they're VMs running within our environment. And Juju is an orchestration tool. all of those three things, Juju, Landscape, and MAS, we actually package into a tool called Autopilot, and I'll discuss that in the coming slides. So if we move on, let's talk a little more about Juju. Juju is a modeling system, primarily a modeling system. And so what we've seen as in fact, back in a few years ago, before OpenStack had really got out of the blocks, we saw that scale-out environments enabled people running VMs, enable people to be able to be agile, spin services up quickly, scale them out quickly if they needed to be able to do that. That also created complexity, and so to be able to it's very common, and I'm sure you've seen this in your organizations, is that when you see tech teams looking at their applications, they'll have a big whiteboard with boxes and lines drawn between them, or sometimes there's whatever, sticky things like that. And that people use to try and visualize, this is my environment. And Juju is, at its kind of base level, it's a modeling tool. So it allows us to be able to model our services, how they connect to each other. Whether it's application connected to the database with caching, with high availability, server in there, etc. To be able to visualize that. And not just visualize the services, but how they relate to each other. So on that picture, you probably can't see too well on the WebEx, but we have two MySQL nodes set up, and that's an HA pair. That's connected with MediaWiki and Memcache and other pieces. And so it allows us to visualize that. This becomes extremely useful, not just when we are designing applications that run in the cloud, but when we are looking at the cloud infrastructure itself, to be able to, because OpenStack is, as I said earlier, it's a collection of different projects and different technologies that we've integrated together. And so to be able to use Juju to visualize the various components of OpenStack, how they relate to one another and connect to one another, is extremely valuable. We keep moving. On the next slide, Juju really is to say to part of this visualization, part of this modeling is to help us solve these kind of fundamental problems, right? Which is how can I deploy, right, my architecture? How can I construct my architecture, deploy that, scale it out, and integrate the various components as quickly and easily as possible? And that's what it allows us to do. So deploy services onto bare metal, so we can deploy Nova onto bare metal or Horizon or Glass or the OpenStack components. We can deploy services into clouds, and that could be deploying MySQL into OpenStack, or indeed some other platforms too, some public cloud platforms too, or into containers. Containers have obviously become hugely popular in the last year, as they've really sort of captured the imagination of developers there, looking to be able to do things quickly and portably across different environments. And so Juju allows us to deploy services into containers in multiple different environments. Of course, containers can be deployed into VMs, they can be deployed into clouds or into bare metal servers too. So Juju is really designed to solve those three problems: deploy, scale out, integrate across multiple different platforms or substrates, as we sometimes refer to them. On the next slide, we talk about this problem of complexity at speed. And I just talked about some of this, but as being able to scale up Hadoop, for example, being able to scale up an OpenStack cloud into hundreds or even thousands of nodes, gives us huge capacity and allows us as a business, if you're, to be able to do things that you couldn't afford to do or were going to be too complex to do previously. And so that's as a business, is hugely valuable. I can get better insight from data analytics. I can be able to deliver faster services to my end users, hopefully faster than my competitors. Great, but deploying, integrating, and scaling those services can be hard. Being able to scale them, manage them, integrate them when there are thousands of potentially thousands or tens of thousands of VMs became that challenge. And so the tool set with Juju, if we move on to the next slide, allows us to be able to do that. Now, a lot of people may have already made investments or worked with tools such as Puppet or Chef or Ansible or Salt, or there's a great many of them out there, config management tools, automation tools. Juju's not manifests or chef recipes. You can embed that puppet script, chef script, or whatever, into the Juju service definition. So because Juju is modeling a service, the service must be defined. That's actually defined in something called a charm. But then the charm can be written in multiple different languages. Bash is typical, or Python, of course. But in those services charms, you can absolutely embed your puppet script or chef or Ansible or Salt or whatever it is, and reuse that so that make use of the investment that you've already got, make use of the know-how that you've already got in those config tools. We keep moving through. A charm, as I say, is that distillation of best practice. So probably the easiest way to describe the purpose of a charm is that when you're deploying a service, and just take an easy example, say a MySQL database, what you really want is, well, what you either have to do is read all the documentation and read the books and make sure you fully understand it, and then apply that to your environment and think, okay, this is the right way I do it. Or, if you could, go and hook up with the person that wrote the book on how to deploy MySQL, and say, how do I want to do this? Right? What's the best way to deploy MySQL for this type of environment? And so a charm is actually a definition of, well, how we install MySQL, where it comes from, which archives, which versions, but then also if we want to do things like set it up in a active-passive HA cluster, if we want to be able to set up replication, these various pieces, all of that we define within the charm. And so it's kind of analogous to getting connected with the person that wrote the book on it, saying, how do I do this? And they'll say X, Y, Z, and off we go. And so we take a look at, for example, the charm for MySQL is very comprehensive. It has a lot of contribution from some of the world's, MySQL experts, and some of the people that are running MySQL at scale in environments, and some of that distillation of best practice and knowledge. So it means that you should be able to shortcut to a highly performant, well-configured implementation of MySQL in your environment, leveraging or piggybacking, as we'd probably say in the UK, on a lot of the great work that other people have been doing. And that's the open source way, of course, right? It's together we all get better by sharing, and therefore, and there are great many charms now. So I've obviously used the example of MySQL, but we've got hundreds of different charms for different types of services, and some very new ones, very relevant ones that I know that's what we're going to be talking about a little later on here. Charms can, of course, be connected into bundles, that we call them. So whilst I can model and define my services in Juju, MySQL connected to whatever Memcache and MediaWiki and those types of services, I can then export that as a bundle, and that allows me to be able to reuse architectures across different environments or across different teams very, very easily. I can export bundles and import them into different environments, shared as YAML files, as it says there, to simplify a lot of this collaboration and sharing. And we keep going. How are we doing for time? Yes. So I'm not a particularly wealthy man, and so as I look to try and increase my wealth, look at the stars that did that, and John Rockefeller was certainly the wealthiest man in the world at one point, and is still considered wealthy even by modern standards, I think. But his secrets to success were that get up early, okay, more time in the day, work late, okay, so I think he's saying work a lot, and strike oil. And then I'm sure he did the first two. He certainly did the third two as well. But I think he's using that metaphorically, right? Which is you want to find the thing that has huge value. If we move on to the next slide, this probably quite poor explanation or example was that we saw that the integration of OpenStack components was problematic, and therefore, if we managed to solve that problem, we could create huge value. And that's because there's a great many projects in the OpenStack community, and there's a great many third-party technologies that end users want to be able to connect with them. So we set up something called the OpenStack Interoperability Lab, OIL for short. It's based in Boston. It's hundreds of nodes now that we use to build around 100 clouds. So we do 100 builds of OpenStack near enough every day there. And we do that using, of course, OpenStack at the top. We see identity for Keystone, Nova, Cinder, Neutron. But we do that then using different pieces of third-party or complementary technology. So, let's build a cloud with Nova using KVM. Let's do another one using with Nova and ESX. We can do Ceph for storage on Cinder. We could do Ceph for storage on the block storage level. Let's connect it to a network, with PLUMgrid, or let's try another networking technology, all of these things. And that allows us to get a very, very clear picture of which technologies sit well together, are integrated well together, and that we're able to support with a customer. So when NTT or whoever it is comes to us and says, right, we're running PLUMgrid and we want to do that in conjunction with ESX and we want Ceph on the storage, we can say, yep, we know it's a good working config, right? And we've got the stats and the data to be able to show that. And so OIL is what really allows us to be able to provide very robust delivery of an OpenStack distribution in conjunction with these third-party products. If we keep going through, we'll see a great many different partners in there. So I think there's 30 plus now, something like that. But the big names that stand out, of course, PLUMgrid you see, but others, Intel, Dell, HP, EMC on the storage, and to Open Compute if that's interesting to you. So a great many different networking technology vendors, hardware vendors, software vendors now participating in OIL, being part of those different combinations of builds that are happening every day. Next up, we see that this is a great environment for evaluating SDNs. So a lot of the value that we bring and have working with PLUMgrid is that we're able to test PLUMgrid working in conjunction with different hardware from Dell, HP, Lenovo, OCP, Quanta, all sorts of different ones too, different types of storage technologies, different types of hypervisors. And so if you are looking at different SDN technologies today, and presumably you are, then the ones that we are testing, such as PLUMgrid, that we're testing in OIL, that we're being able to stand by and say, this works, this is a valid configuration, this is something that's supportable between us. And keep going through, we'll see that on the sort of final manifestation of this is when we get these working, these known good configs that we can see that we're pulling from drunk. We do a lot of CI testing actually, so continuous integration testing. So we pull from trunk all the time. We run the in OIL builds against current versions, against release candidates of OpenStack, so we get to be able to see what's happening upstream too, and whether that's compatible with current versions of partner technologies too. It means that when we get to an OpenStack release, we're able to fold that. We know that these combinations of technologies work, and we put that in what we call the autopilot. The autopilot is a single pane of glass. It's a UI management, deployment management and monitoring framework that builds on top of the tools now, Juju and Landscape. It allows us to be able to install known good working combinations because they've been proven in OIL. And very much part of that roadmap you'll see is PLUMgrid to be able to come into the autopilot, so that you'll be able to select it, install it as part of the implementation, with the comfort that it's been proven through the testing in OIL. We keep moving on, just looking at time. I'm need to keep moving and give Azmir some time to talk about PLUMgrid and Open Networking Suite.
All right. Well, thanks, Mark. That's really helpful. I know, when people think about Canonical and Ubuntu, I think probably the first thing that comes to mind is definitely the Linux distro. Everybody's probably running it on their desktop or on a server. But obviously, as you can see, there's a bunch of other things here that that the team is doing to really bring OpenStack into production, really, validate, do a lot of the hard work, frankly, upstream, do it in a very open and partner-friendly manner. And I think, and I think for us, we see OpenStack as an ecosystem play. There's not one product that you can buy from one vendor to make your cloud, ready and agile and scalable. I think it requires open APIs, open ecosystems, and I think Charms and Oil and Autopilot really allows vendors to have that canvas to really work together. So I'm on behalf of PLUMgrid really grateful that Canonical has put this framework together. So let's switch gears a little bit, and then we'll intersect here in terms of sort of what PLUMgrid and Canonical are doing. So PLUMgrid, just a quick run through if you haven't heard about us before. We are an SDN vendor, software-defined networking. Our product is called PLUMgrid Open Networking Suite, and what we deliver are a library of virtual network functions, and that's what you see in that purple box over there. So we have bridge, router, NAT, DHCP, DNS, firewall, and there's others that are coming through. But we also don't lock you into just our VNS, so virtual network functions. We also allow you to onboard physical, virtual, and container-based VNS from third parties. So if you've got a firewall or a load balancer, whether it's a physical or virtual, we'll be able to stitch that onto what we call our network fabric. And how we present it to you is in this notion of a virtual domain. So think of your virtual domain as your virtual private cloud. You have, and the same thing that you can do, same thing you can do with a virtual machine, power it up, power it down, clone it, move it. Think of a virtual domain in the same way that you have this network topology that you could power up, power down, clone, and move. And so that level of flexibility really is very cloud-centric, allows you to build very, very sophisticated network topologies and be able to be very flexible about it and make it available on a multi-tenant environment. And the best part about this, Mark mentioned about Oil and how there's multiple, hundreds of servers running in there, is that when you go to networking, it's traditionally been a very vendor-specific implementation. And so what we try to do is to really run as an overlay that can run on any physical network infrastructure. So that way, and a lot of the forwarding actually happens inside the compute nodes and before it traverses the network itself. And so all this ability here gives you a lot of agility and flexibility to deliver value in this era of cloud. So let's talk about what PLUMgrid and Ubuntu have been doing. So our first public announcement was that we joined Oil in middle of April, and we joined the other ecosystem partners who really believe in this concept of interoperability, testing upstream, because we've seen ourselves the challenges you have if you just show up at a customer site and try to deploy OpenStack and our solution together. There's a lot of moving parts. All these things need to shake out, and the more testing you do upstream, the better experience you will have. And so really something that, Oil is something that we really believed in. But we didn't just stop there. We wanted to also enable people to deploy our product on top of Ubuntu OpenStack in a very simple, straightforward manner. And of course, Juju Charms allowed us to go do that. So we went ahead and developed our Juju Charms, and there are currently early access versions right now on the Juju Charm store to really double down on the relationship. Then the third part of that is that we've updated those charms and we're going through validation of those charms through Oil. Again, I think that third piece of the trifecta, if you will, is really important for us, because we feel like that is how we really align with Canonical, really align with what we think the market is expecting in terms of deploying OpenStack with confidence, deploying PLUMgrid, interlocking that within the OpenStack ecosystem in a very simple and straightforward manner, and provide that flexibility and confidence that they need. And of course, to top it off, we have this joint webinar, and there'll be more things coming along here in Q3, but definitely want to let you know that in a very short period of time, both companies have really aligned together, really delivered stuff that's tangible, because we do believe in the common goals of really providing a better solution for customers building clouds. So in terms of Juju charms, just to double click on that, so the ones that we have really are representative of the components in our system. Let me spend a bit of time here on the items on the left side of the page. So our director is our control plane. So that is where we make all we render topologies as people come in, tenants come in and they build topologies. The director is the one that will propagate that out to the compute nodes. The edge is our data plane. Some of you may have heard IO Visor being mentioned in relation to PLUMgrid, and that's our layer 2 to layer 4 forwarding engine. It sits inside the compute node. It really sits next to the hypervisor. We've actually upstreamed it into the Linux kernel, so it's extremely fast. So it runs in kernel space, so user space, and it actually does a lot of your lookups L2, L3, and L4 inside the compute node, and so that highly efficient, provides ability for us to do scale out architecture, all the goodness that you see in cloud. The third component is the gateway, and think of this as the border between the cloud and the rest of the world, whether it's the internet, whether it's a legacy network, whether it's the rest of your corporate network that's not part of the cloud. And what the gateway does, it's inside the PLUMgrid zone, all traffic is sent encapsulated inside a VXLAN packet. And when it traverses out into the internet or the legacy network, that needs to be unencapsulated. So the gateway really does that. And we support gateways to either be software gateways or you can run as hardware gateways. The last two are not directly part of the PLUMgrid system, but something we depend on. Obviously, inside OpenStack, your network interface, your APIs are driven through Neutron. And so our Neutron plugin provides that layer of abstraction, that layer of translation between OpenStack to the proprietary PLUMgrid implementation. And then finally, IO Visor. IO Visor really is the actual data plane. And as you can see in the picture here, there's the relationships that you build, the bundles that you build for your Juju charms, and it's a very graphical, very declarative model, and really allows you to ensure that, look, when you want to build a cloud that has all these SDN components that are the relationship is this way, you can actually visualize it before you actually go ahead and deploy, and that provides you a lot of confidence, a lot of repeatability. And as Mark mentioned earlier, because you're potentially leveraging your existing automation frameworks, you can still do all the troubleshooting that you need and use those tools, but also leverage the framework that is Juju Charms and really accelerate your cloud deployments. So I'm going to pick some questions here that came in because I think they're relevant to just what we talked about here. So one of the first things that came out was whether we use network nodes. The answer is no. We don't use network nodes, and we don't use L2 and L3 agents. The IO Visor does all of that forwarding inside the compute node. And so if you were to look at any traffic flows, the traffic flows are what we call east-west traffic. So if a VM is talking to another VM, and let's say you need to traverse a security group or you need to traverse some sort of router in the topology, all that forwarding is actually done inside the IO Visor, inside the compute node. There is no need for you to leave the compute node to go to a network node somewhere out, maybe most likely on the OpenStack controllers to make that forwarding decision. And so that provides you extreme flexibility in terms of scale and performance. Same thing applies to L2 and L3 agents. Because all the lookups are being done inside the IO Visor, there is no need to have agents. The other question was virtual network functions. what are those available? So walking up the OSI stack, we've got a bridge, we've got a router, we've got a firewall, we've got NAT, we have DHCP, we have DNS. We have a couple other ones that don't have an exact equivalent inside OpenStack, but we've seen people use them to configure more complex environments. And of course, we support a lot of third-party devices that you can stitch in. And actually, that's probably one of the key selling points for our platform, is that we're open. We have a generic way to onboard devices that are physical, virtual, and even in Docker containers into our fabric. So, and moving on. So, but the value of PLUMgrid really is more than just the product. We spend a lot of time. We know that building clouds are hard. Clouds are new. There's a lot of moving parts. There's sunk costs, specific training that people have done. And so we really work with the team very early on designing the architecture. And, we actually was on a call today. We've got a large financial services company that we're working with. We've got a fairly large environment, and we've really been working with them for the past couple of months on architecting and prototyping what the network looks like. And then we generally work hand in hand with the distro partner, whether we collaborate on things like Juju and Oil, to ensure that the product has integrity and has everything is done. And then we'll actually follow through with the actual use of the cloud, the kind of use cases that people have, and also we invest a lot in terms of operational tools. So one of the things that people choose us for is something called PLUMgrid Toolbox. It's a collection of tools for pre-deployment, runtime, and post-deployment operations. So whether you want to find out if everything's configured correctly or if things are running as is, you want to do a trace route, a ping trace, do a packet capture, all of those things we have. And then we spend a lot of time also on maintenance. We have customers that have been running in production for more than a year, and they've at the point where they want to do upgrades. They need to do audits, and those are the things we help people do. And we bookend those really with teams that provide a lot of help upfront on the design and also a lot of help on the back end around support. From a product standpoint, we integrate primarily using the Neutron plugin. And so that provides us a zero-day compatibility. So Mark answered, what version of OpenStack is supported, Icehouse, Juno, and Kilo. We had Kilo support before Kilo was available at the end of April, because we had upstreamed all our Neutron plugins. And the same way that Oil and Autopilot does a lot of this testing upstream, OpenStack has an equivalent CI system, and so we take advantage of that. So providing day zero compatibility is important, because we see that in the market that people want to be on a relatively new version of OpenStack. Around distributions, we've talked a lot about that. We really try to keep in lockstep with the distro partner, spend a lot of time talking about what roadmap, and also spend a lot of time on certification. So Oil really is for Canonical, where we're spending a lot of time there. And then tangentially to the distros, we also work with a lot of networking partners to allow service insertion and chaining. We do a lot of compatibility and also do a lot of certification. So our goal is to really do a lot of hard work upstream, so that when we are on site, it's as easy as you can get in terms of coordinating all these ecosystem solutions together. We also get asked, hey, how do you improve networking, right? Because a lot of these distro vendors already have a networking stack that's built around Neutron in their distros. And I'd say in the early phase of OpenStack, as you're going through your proof of concept and you pilot, there may be certain things that drive people our way, whether it's a complex topology, whether it's a design, whether it's really embracing SDN and education around it. We do that, and so we have tools like our Ignition Sandbox that allows you to really test drive our functionality. We have a lot of information available on our website. We really make it available to people to go try it out. What we really separate from the pack is when you go into production. So somewhere in that pilot to production is really where you see a significant amount of our value, because we provide via a virtual domain that provable isolation. We could really, as I said, have multi-tenancy in a way that it's configured that you can clone and move that virtual domain to anywhere you want. Because of our architecture advantage, we have class-leading performance and scale. High availability. So I'd mentioned earlier around our directors and our edges or our advisors as being two components. One's the control plane, one's the data plane. The way that we've architected our system, they are completely separate in the sense that, and we've done this in previous demos, where we actually will shut down our directors. We'll actually kill them altogether. You'll actually see that your data still flows. And that's really important in the cloud because, SLAs and maintaining the uptime of your cloud is very important. So we feel like we have a lot of value there in terms of really separation of that control plane and data plane. Extensibility, so we see that with the ability for us to service chain different devices. We have a significant amount of APIs, both Neutron APIs, and also we have a class of Neutron extension APIs that go above and beyond the stock Neutron setup. So that allows you to really build for the future, build things that you don't even know that you need today. And so that is code. We spend a lot of time on QA, again, by what we do in-house and also with the things that we do with our partners, really hardening the code. And I mentioned earlier on operational tools, we have a lot of people that really need things. Like for the things that bring up a cloud, once you've got the recipe correct, it's fairly repeatable, but operational tools are when things go wrong. If you've got a bad NIC, a bad switch, something changes inside things. All those things it could take days if you don't have the right tools available to you. And what we've seen, for as good as the Linux tools out there, they're not really tuned to go do things for the cloud. And so we built a class of tools that allow you to really focus on networking issues when you've got your cloud in production. In terms of use cases, we've seen this, in addition, once you get into production, these are the driving forces for why people are embracing OpenStack and why they need SDN. I'm going to go quickly through them from left to right. So platform as a service, a new way for you to build your applications. If you've heard about Cloud Foundry or Open, a bunch of other options available out there in the market. Those are the ways that people are using building applications on much more lightweight, much more agile, but very scale out and very cloud friendly. And then there's CRM. You've got retail. You've also Hadoop as a service and also communication service. And this last one here is very interesting because this is where you've got a complex topology and you're not really using Horizon to go implement these. You're using those APIs that I mentioned earlier. You actually will just run a script and it will actually build your network topology for you and actually will allow you to go create these call centers, literally at a click of a button. And so there's a lot of value that we're seeing there, and all of this is running on top of OpenStack. So in general, we're seeing a lot of new apps and new ways to leverage the cloud to use both OpenStack and PLUMgrid. So in summary, why PLUMgrid? Definitely our technology. We feel like we've got class-leading technology. We've been shipping our product for more than a year. We've been integrating with the leading distros, Ubuntu included. But we don't feel it's just that. We feel that our team, we're class-leading industry veterans in the networking space. And then we also help you, as I said, very early on in the cycle. It's not just about, download our code and off you go. I think, it's most people understand that it's more than that when you're building a cloud. Then we're really great partners. Hopefully that comes through here in terms of what we're doing with Ubuntu. But we're also, we're the no agenda SDN vendor. We just want people to embrace SDN as they build their clouds. So with that, I'm going to see, before we go do a walkthrough of the Juju Charm store, let's see if there's any questions here that we haven't answered yet. So we've covered the one around network nodes and L3 agents, network functions. So Mark, just to, I know so you answered the multiple versions of OpenStack, Icehouse, Juno, and Kilo. For oil, do you guys test Icehouse, Juno, and Kilo, or you're all mainly testing sort of, you said, trunk? What's the latest version? What's master on OpenStack? How does that work?
So we're mainly testing stable, which is of course Kilo right now, and then we're not testing. We don't test anything sort of generally pre-release candidate. So which generally comes in about sort of month 4, sometimes month 3, but month 4 of the 6-month development cycle. So we'll start testing around then. But we do test, do a lot of test runs on earlier releases too. So Juno, there's updates, whether it's security patches or whatever, those kind of things. So we'll do this. But most of the focus is around stable, what's current today, and then at the right time in the cycle, what's coming down the pipe.
Yeah, and if I remember correctly, as a partner, once I have our charms inside Oil, as let's say for example, there's a patch set that comes through inside OpenStack, and somehow that breaks some component of PLUMgrid, one of our charms, we'll get notified of that very early on. So even before it reaches any customers, we'll see that, and some notification come through. Is that right?
That's absolutely. And so, and it's through that relationship that we have with partners like PLUMgrid, we can say, okay, we see this issue in the Liberty, so we've just got the new release RC1, or we've got first drop of Liberty that's coming down, and we've seen in this combination, and it could be a certain type of hypervisor using a certain type of storage with a certain type of physical network switch, for example. We see this strange behavior, and so it gives us time collaboratively between the partners to figure out, okay, how we're going to fix this and ensure that at release or very soon after that we've got something that we know is supportable, it's robust and reliable, and we can get it into the hands of the customers.
Yeah, and I think also there's a second benefit too, is a lot of times customers are coming to us and asking, hey, what version should I use? And that's true for PLUMgrid and also true for Ubuntu OpenStack. And I think that data helps because I think, as I said earlier, the market very much is young, and people tend to want to be on the cutting edge of where OpenStack is. You mentioned Liberty. Here we are talking about Kilo, and that's what's stable, but Liberty is not that far away from here. And so I think having that data gives us that early warning system, if you will, to our channel partners and to our customers around hey, we recommend that you stay with Kilo. Liberty's great, but until we solve this issue over here that we've detected very early upstream, it's just easier to do business, to deploy your cloud by using maybe a -1 version relative to what you would like to do, right? I think that helps, and us having the same data, helps customers too, because I know that customers tend to check with vendors and tend to get opinions, and if we have something that's concrete and real time, it really helps that communication out to the customer.
Sure. Just as a kind of follow up on that, one of the questions that came from Rolando was asking about is this open to the community, and the answer to that question with anybody that's developing technology complementary to OpenStack can come and participate in Oil. However, this is not. We don't publish publicly test results on a daily basis. So because a lot of this, as you can probably imagine, is commercially sensitive data. If we detect an issue in a certain vendor's software or hardware technology with a given release of OpenStack, that's commercially sensitive. It could well be Ubuntu, of course, So issues. So this is not things that we publish out there. We want to give people a chance to understand that there's a fixing issue and in this type of combination. A lot because we get that, as you said, those same questions. Should I pick vendor A or vendor B? What does your testing tell you is going to be the fastest or the whatever? And that's not necessarily the purpose of this, right? The purpose is for us to be able to work collaboratively with our partners and identify issues via the early warning system, if you like, that you described, and get them fixed so that when people determine, PLUMgrid's going to be the right solution for me for the various reasons, that they know that it's going to work reliably and robustly in a supportable way, between Ubuntu and PLUMgrid.
Yeah, and again, just to add on that, I think obviously there's multiple steps to this. So Oil definitely is one where we want to go, catch things early on in the system so that there's less friction as we get closer and closer to the customer. but we do want to be transparent about things to a certain degree, right? Again, if a customer came to me and said, "Hey, how come you're not recommending this?" I'm more than happy to say, "Look, we found this issue, and this is where we're working towards it." I think, but I think that gives you a much better view to the customer than you would, let's say, in a closed ecosystem where it's just one vendor and they're making stuff up. And so we do want to provide some level of transparency. But to Mark's point, we some of these things are transient, and so we don't want to put out something out there that may not be meaningful in 2 weeks. And so I think a lot of times when people look at reports and whatnot, there needs to be a timestamp. If you don't follow through, then you have the wrong view of things. I want to pick on Docker networking, Mark. So I actually just want to share with you some things. We actually have a customer where because of the support for Linux containers in Ubuntu 14.04, that became sort of the default choice for the Linux distro or for their OpenStack cloud. And so that was great. So for us, it was we run our directors inside Linux containers, and they actually sit. You can sit anywhere, if you will, inside the cloud. We generally co-locate them on the controller nodes, and because Ubuntu 14.04 had great support for Linux containers and no dependencies, we're able to just go in and deploy that. So I think kudos to the Ubuntu team for really being very very Linux container and Docker friendly. And then in terms of Docker networking for PLUMgrid, we actually had a session at the OpenStack Vancouver Design Summit. We actually, and you have the video and the slides are available on our website, and talk about that. Docker is still very early on. I think I think as Mark mentioned earlier, it's getting a lot of mind share inside the developer community. But from but there are a bunch of things. There are a lot of open questions that are still being answered by that ecosystem. So there's no specific direction where things are going. So we're staying close as a company in terms of that because it's very interesting for us. We want to solve networking problems, whether they're physical, virtual, or container based. But you can definitely see sort of what our current thought process is relative to Docker networking in there. And again, I don't know whether you can actually see my browser screen or not, but if you can't, there's a website called jujucharms.com, and that is where that's the Juju Charm store. And then if you go in there and look for PLUMgrid, you'll be able to search for PLUMgrid, you'll be able to see all the charms that's available on the store. So these are our early access charms. If I'm not mistaken, I'm just going through here and take a look. Yeah, these are the early access charms. Definitely good for you to sort of try out and add to your demo. We are undergoing validation now with in oil, and once those are done, I think these will get updated here in short order. So, but definitely that should not stop you from checking out what we've done so far. I think there's a lot of goodness there in terms of what's available on the store. So with that, I think we're almost to the top of the hour. I appreciate everybody joining us today. Mark, any last words here before we end the webinar?
No, just to reiterate what you said. I mean, please do go and check out Juju, jujucharms.com. There, take a look through, find the instructions how to get going with Juju, and of course the PLUMgrid charm. So encourage everyone to do that. Excellent.
All right, and then if we didn't get a response to you here live, we'll definitely spend a bit more time here answering questions in the Q&A panel. But please visit our websites, plumgrid.com, and also Canonicals, and then and definitely check out all the great work we've been doing together. And with that, thank you very much for joining us today. I appreciate it, Mark. Thank you for joining. Hopefully, not too late for you where you are. Excellent.
No, all right. Thank you for letting me join. Goodbye.
Okay. Thanks everyone. Goodbye.